The planet is heating up.
The oceans are becoming filled with plastic.
Change starts now. Change starts now.
We're on a countdown
To zero waste. 5, 4, 3, 2, 1.
This is the Zero Waste Countdown Podcast. Here's your host, Laura Nash.
Hello, everyone, and welcome to the Zero Waste Countdown podcast and radio show. Today, we're speaking with Melanie Bergman about her study. She found plastic in snow in both the Arctic and the Alps. Melanie, I don't want to do a disservice to the German language, so can you say your university for us?
Yeah, it's the Alfred-Wegener-Institut for Polar and Marine Research.
Awesome. And then you're part of the Biosciences and Deep-Sea Ecology and Technology department, is that right?
Yeah, I'm from the Deep-Sea Ecology Group.
Awesome. Okay, and so Melanie, you led a research team looking for microplastics in snow in both the Arctic and the Alps. So tell us about why you chose those two locations.
Yeah, the background of the story really was that we found these really high microplastic concentrations in samples of sea ice and of deep-sea sediments in the Arctic. So we were asking ourselves, where does it all come from? And one possibility is, of course, the atmosphere, since the colleagues from France and also China have shown that microplastic is in the air. So it could well be that it's transported with the wind, for example. And because snow is a known scavenger of particles entrapped in the air, we basically chose to sample snow because that's more easy compared with putting out instruments on ice floes for a year in the Arctic.
Mm-hmm. And there was a comparison between the Arctic and the Alps, right? So was there more plastic in the Arctic or was there more plastic in the Alps?
We did not only sample in the Arctic and in the Alps, but also in the city of Bremen on the Isle of Helgoland, which are northern Germany. So this is also interesting. And basically, we compared the amount of microplastics from European samples and the Arctic samples, and it was a lot higher, of course, in the European samples. But even in the Arctic snow samples, we found up to 14,000 particles per liter melted snow.
Oh, my goodness.
Although on average, it was more about 2,000 particles per liter snow. So,
and
yeah,
how many?
Quite a significant amount considering the remoteness of the place.
Yeah, it's quite sad, but very important findings. And how much was the concentration in the European areas that were closer to cities?
In the city of Bremen, it was that was the most urban site. It was around about 2,000 particles per liter melted snow. So yeah, also quite a lot, but not anywhere near as high as those from the Bavarian Alps. And in that one sample, which was the highest of the whole study, we found more than 150,000 particles per liter melted snow. So, yeah, that
goodness.
really was a huge amount.
And really, when you think about the Alps, because they're so high, I guess there's no other way of getting that plastic into the snow other than, I guess, the atmosphere, right?
Well, that particular sample was taken next to a country road. So, I mean, it's not in the middle of a city, but still there may have been some traffic prior to our sampling, which could have swirled up any particles on the road, possibly. So, yeah, that could have played a role. It's not like a pristine part of the Alps. That was more likely in the Swiss Alps, where we also took samples, and indeed, those were amongst the lowest concentrations that we found.
I read in the study, too, that you found concentrations of rubber from car tires. And was that found in the Arctic as well?
Yes, we also found rubber particles in the Arctic, but I would not say, well, we cannot really pinpoint it to car tires because rubber is used in many different applications. And of course, It is likely that they may have come from car tires, but I would still not pinpoint it really directly to that cause because at the moment we cannot really tell it from our analysis.
Mm-hmm. And I've heard that it's difficult to tell where the types of different types of plastic comes from because it's broken down so small that you can't see that it's a water bottle or you can't see that it's a shirt anymore. Were you able to kind of differentiate other than the rubber, like other types of plastics? Like what kind of plastics did you find in the samples?
We also found a lot of particles that belong to a group which comprises varnish, polyurethane, and acrylates. And these may come from paintings or coatings of surfaces, maybe from cars or house facades or ships, offshore platforms. We can, again, not really pinpoint it to a direct source, but those are possibilities. We also found polyamide samples in our samples, polyethylene, which could come from packaging material. So, yeah. But there was a big variety of different polymer types that we found.
So tell us a little bit about the scientific process of finding, your findings, I guess. So how did you guys analyze the samples to find the microplastics? What was the process?
Well, the first thing was to go out and take the samples. In the Arctic, we used a helicopter or a dinghy to approach an ice floe, and then we basically used a sophisticated spoon, scrape off the surface snow and put it into our jars. And then in the laboratory in Helgoland, we basically melted the snow and filtered the particles in it, and then it was subject to what we call Fourier transform infrared spectroscopy. And basically here you get a spectrum for each particle on the filter, and this is matched up with a reference library of known particles, and then you get a match for a different polymer type.
Oh, wow.
And can say so and so many particles of polyethylene, so and so many polyamides, and so on. So, yeah, then you get a composition of the particles in your sample.
Very cool. So I'm not a scientist, but I love science. So I'm just trying to get a visual. Are you kind of like shining a red light on different things, and then the way the light interacts with the particles, then you would reference like the amount of light that goes through or something? Is that how it works?
I think that's how you could say, yeah, that's how you could explain it more easily.
I try to explain things like I'm 5 sometimes so that I can try to understand what you guys are doing out there. So there was one spot that you tested that didn't have any plastic, or were there many sites that you tested that didn't have any plastic?
No, there was just the one site, and basically at that site we also found microplastics, but we also took blank samples and subtracted the amount of particles that we found in a blank sample with the ones that we found in a sample, and because of that, there were 0 in the end in that sample. So, yeah. The reason why we take these blank samples is, of course, that you have to take account of contamination of samples. I mean, we're surrounded by plastic everywhere. Mm-hmm. When we do our analysis, we try to, we wear cotton lab coats, we have a clean bench, and air filtration system. So we try and avoid it as much as possible, but it cannot be excluded totally. So to account for this, we take these blank samples, and
What do you mean by a blank sample?
Basically, you put a filter or water and process it in the same way as you process your sample, and if you found any particles in it, then you subtract the amount of particles from your sample.
Oh, I see.
So in this way, you can subtract possible air contamination.
And the spot that you didn't find any or very much contamination, I guess, it was in the Arctic, I would assume. Was that the lowest concentrations? Yeah. But it's still crazy that it's up there. It's kind of sad to think about, actually.
Yeah, and I mean, that was just one of quite a few samples.
Yeah. Why are there high concentrations of microplastics in the Arctic surface waters when there's so little human population up there? Is it because all the currents of both oceans are pushing up into the Arctic?
Are you talking about water samples or snow samples now?
Water samples.
Because on water samples, we have not published yet. We've published on sea ice, and the sea ice comes from the water samples, so I guess you could conclude that we have high quantities in the seawater. The microplastics in the seawater likely come from the ice when it's melting in the Arctic, but also get transported to the north with the thermohaline circulation, so basically the Gulf Stream, which delivers particles and water to the north.
Because I think I read about you that you have done a study as well on microplastics. Was it in the Arctic seafloor or was it in the water?
We have looked into sediments of the seafloor, and there we found huge amounts. We found concentrations of around about 6,000 particles per kilogram sediment, and that's a lot.
Wow.
And that could come from local inputs because, of course, there's more and more traffic in the Arctic. It could come from Europe and be transported to the north with the thermohaline circulation. It could also come from Central Arctic, delivered to the study area, which is the Farm Strait, with the ice, because that drifts to the south with the transpolar drift from the Central Arctic. Yeah, so there's various possibilities. But, of course, one important mode of transport could also be the atmosphere, since we found these high concentrations in snow.
So the atmosphere is kind of raining down plastic in snow, probably, and then it's getting in the ice, and then when the ice melts, then it could be releasing into the Arctic water and getting into the seabed sediments. Yeah,
or it's directly snow falls onto water and is then transferred to the water and finally to the ocean floor.
I wonder what samples are like near cities. If the seabed concentrations are so high in the Arctic, I would assume that they would be just crazy high around big cities. Did you compare any data of city seabed contamination?
The problem with this analysis is that every lab does it in a different way.
Oh, yeah.
So it's very hard to make comparisons.
Yeah.
But we also analyzed samples in the same way taken in Norway near city and also near to where they used to dispose of sewage sludge, and there they found much higher concentrations. And but on the other hand, if you compare our samples from the seafloor with those from the North Sea, for instance, which is of course much closer to potential sources, there were around about 1,000 particles per kilogram sediment, so they seem quite a bit lower on average, and that was exactly the same methodology used.
Wow. So it almost seems like the Arctic is, like, I don't want to say a dumping ground, but like it seems to be accumulating microplastics from around the world, possibly.
Yeah, it looks a little bit like that, and that could have to do with the water circulation patterns, bringing it to this area from different directions, but also in terms of the winds, which also bring particles from all these different directions, from North America, Western Europe, the North Pacific, East Asia, the East European and Siberia. Basically, it may concentrate particles in this area.
Mm-hmm. Jay Branda said he also found Teflon on the seafloor, which I thought was really weird. And he said he had no idea where it came from. He's a scientist from University of Savannah in Georgia, and that was one of the most prevalent things they found, I guess, which is weird.
Yeah, I've seen it in several studies, and we also found it in our studies. The bigger particles from the seafloor samples were that material as well. Yeah.
The only thing I know that Teflon is used for is nonstick pans. And I mean, maybe it has other uses. I don't know, but I wonder if like it's from people washing their pans or something. I don't know. Or maybe it was dumped a long time ago from companies.
Yeah, but maybe it is from washing, because the sewage treatment, of course, only retains a certain amount of the microplastics in our water. And yeah, so if you often these pots that we use are actually not intact anymore. It's a lot of scratches and stuff, and maybe once the surface is damaged, then you lose more and more of these particles. That's quite interesting. I never thought about that.
Yeah, you see people's pans all scratched because they use forks. I know my mom used to freak out if we came anywhere near a nonstick pan with a fork because it would get all scratched.
Not so clever.
You found some natural fibers too in the snow samples, which I found kind of interesting because I think that kind of shows that, like, I think fur was one of the things you found. So that's obviously something that can travel in the atmosphere, and we know that. What are some of the other things that you found?
We also found plant fibers. We found also minerals like coal.
Coal?
Yeah.
Ugh.
So there's a whole range of different particles.
Yeah.
Basically.
So let's say I have a plastic bottle in London or like, some big city in Europe, and I just like put it on the ground and I don't know how fast things would get into the air from that, but do you have any idea of how fast microplastics could travel from any cities that we know in Europe to the Arctic? Like, is it a few days of wind travel? And do we know this from some of the natural fibers, or is it too hard to tell?
Well, there's been one study which basically found that pollen from pine trees and willow trees, I think, traveled to the Arctic from Central Europe within 5 days. So that's really fast. Also, there has been a study where they detected dust from the Sahara, rather big particles actually, which is to the northeast Atlantic, which is a distance of 3,500 kilometers. Although they didn't state how fast these particles had traveled, so how long they were on the way.
But we definitely know that things are moving around the world in the air, and I guess now we know that plastic has joined it, so it's in the air, which really disturbs me because I don't know if I'm breathing it in. I would assume I probably would be breathing it in, and then I don't know what's going to happen to my body when I'm getting, like, am I getting plastic stuck in my alveoli? I don't know. It's kind of weird to think about.
This is really strange because, I give a lot of interviews, and at the end of it, it's often the question, well, what does it do to our health if I eat a mussel which contains microplastic, or fish which has microplastic? And it's also in the air. So we don't really know what it's doing to us. The only thing we do know is that it has been found in human stool. So, but this doesn't really tell us how it affects us. It just says basically that we've ingested it and egested it. So we don't know what it does to us if we inhale it. Because, there's been one study in 1998 where they found microplastic in human lung tissue. But this is the only study, really. And, the plastic production has increased a lot since then, and not a very big study. So it's a little strange because there's a lot of research being undertaken on the effects of microplastics on animals, yet, very little or none published to date about the effects on humans.
Yeah. I think it's something that people kind of don't want to know about because plastic is such a big part of everybody's lives. And sometimes people will tell me, I had a plastic water bottle, Laura, and I thought of you. And I was like, well, why didn't you just not take it if you thought of me? Because we know that it's a problem, but it's so hard for people to stop because it's so convenient, right? So, I think there should definitely be way more studies on this. And I have never thought of it before talking to you that, yeah, we could have plastic like lodged in our lungs, which I don't think could be good. So hopefully some people study that, and hopefully your study here leads to more studies and make sure that we're okay and see what we can do. Because I don't know, like, is there any way of cleaning out particles from the air, like with some super micro